Hello, this is Chris Maynor coming to you once again from the campus of Union University in Jackson, Tennessee. In this video, we want to discuss the present value of a single amount. In other words, we want to determine the value of a future cash flow. The time value of money tells us that future money is worth less than current money. We're going to find out now exactly how much less it's worth. So you may recall in the previous video we saw that the future value of a single amount is equal to that amount, the amount that we put in the bank, the amount that we save or invest today, multiplied by 1 plus the interest rate to the nth power, where n is the number of periods we hold that principal in the bank, the number of periods that we invest the money. So future value is equal to the present value multiplied by 1 plus the interest rate to the nth power. Well, let's modify this formula just a little bit. Let's do as the mathematicians say, let's solve for present value. And what we see is that the present value of a future cash flow is equal to that future cash flow divided by 1 plus the interest rate to the nth power. Now, this formula is very important. This is what some call the time value of money formula. This tells us the value, the present value, today's value of some future cash flow. We find that present value by dividing the future amount, the future cash flow, dividing it by 1 plus the interest rate to the nth power. Now, this term interest is a little bit confusing because we're not actually earning interest. In fact, we're giving up interest by receiving the money in the future. So generally we don't refer to this as an interest rate, but rather as a discount rate. This is the rate that an individual discounts future cash flows. Again, future money's worth less than current money. And it depends on how impatient you are and how risky the business environment is and how much interest you could earn during that time period and how much inflation you expect. So you may hear me refer to this interest rate as the discount rate. We're discounting future cash flows. So let's go here. You may remember earlier I offered you $1 million today versus $1 million 20 years from now. Well, you know how much $1 million today is worth. It's worth $1 million. Well, how much is $1 million 20 years from now worth to you? Well, the present value of $1 million 20 years from now is equal to 1 million divided by 1 plus the discount rate, and let's say that's 10%, 0.1, to the nth power, and you're receiving the $1 million 20 years from now, so that's to the 20th power. That's 1 plus 0.1. I've done the calculation on this, and this turns out to be 148,643.63. So if I were to offer you $1 million 20 years from now, if the relevant discount rate, if you discount future cash flows at a rate of 10%, then that $1 million is really only worth $148,000 and some change. That $1 million has depreciated, it has been discounted due to the time value of money. And again, this is a very simple formula. Any calculator that has an exponent function, you can use this. However, with the previous future value calculation, we can use an interest factor table. This is the present value of a single amount interest factor table. You'll notice that this is a subset of Appendix B. You have the entire table, Appendix B, in your book, or I've given you a copy. We can use this table, for example. Let's suppose that you're going to receive $1,000 4 years from now. And we're going to keep a 10% discount rate. We discount future money at a rate of 10%. Well, we can use Appendix B to determine the present value. Present value of this $1,000 is equal to 1,000 multiplied by the appropriate interest factor from Appendix B. And since we have 4 periods at 10%, that value is 0.683. And so the present value of $1,000 4 years from now, discounted at 10%, is $683. That $1,000 loses value because it occurs in the future. Again, this is a very powerful concept. This is the concept that we'll use throughout our study of capital budgeting because, again, we're interested in future cash flows, future revenues, future costs, future cash inflows, future cash outflows. And we have to keep in mind that money loses value over time. So this formula, whether you use the formula itself or Appendix B, it's very handy, very useful.